Hello, everyone, and welcome back to Invitation to Puzzles, where today we have a clock lines puzzle by Pallando. So I've never done a clock lines puzzle before, so this should be fun. So the way that these yellow lines work is that adjacent digits on a line differ by either 2 or 7. So it says we should think of this as being 2 hours different on a clock from a planet with a 9-hour day, which I have no idea what that means, I'll be honest. But let's make our very best effort here to understand what is happening, and we'll give it a go. There's a link in the description if you want to give it a go. Let me know if you have previously enjoyed clockline puzzles or if this is your first as well. So I definitely am not differing by 7 from 7 because that would bring me to 0 or 14. So I can only differ by 2, which would mean that this would have to be a 5 or a 9. However, 9 differs from 3 by 6, which is not allowed. So that's a 5. Let's see. Any number that's the only number you could differ from 7, or the only numbers you can differ by 7 from are 1, 2, 8, and 9. So as long as I'm not one of those, I have to be differing by 2. So like 5 and 6, I know the difference is 2. So it's either going to be 4 or 8 here, and it's either going to be 3 or 7 here. However, 4's difference from 1 doesn't work, so this is an 8 in this instance. Just sort of slowly figuring out what on earth I'm doing. 3's difference from 9 is wrong, so that is a 7 as well. Okay, so we got that piece. Let's see. I see that there's an 8 in one of these two cells by Sudoku. Wonderful. I know there's a 1 and a 9 up here. In fact, am I going to just fill in this row? I might just fill in this row. I know there's a 1 and a 9. Can this really be a 1 or a 9? 1 could go to 3 or 8. 8 actually works. I actually know that there's an 8 in this row and a 6. Okay, so these can be 1, 2, can't be 3, could be 4, can't be 5, 6, 7, 8, could be 9. And these are not 1, could be 2, 3, 4, 5, 6, 7, 8, and can't be 9. So these are, wait, are these just 2, 4, 6? Did I, oh yeah, these are absolutely 2, 4, 6. Wait, how did I screw this up then? Sorry. Oh, it's 2, 4, 6, 8. Sorry, these see all 5 odd digits through there. So these are definitely even. So they're from 2, 4, 6, 8. Okay, then okay, so I probably should think something about that fact that these digits are even for sure. So these digits will be... Okay, well, here's an interesting sort of corollary of this, which is that these two digits see all but one odd digit. So they're even unless we have exactly... Oh, well, how about I just do this the easy way? There's an 8 looking across here, there's an 8 looking across here, and there's an 8 looking up here, so this digit's just an 8. That sounds like a better way to go about doing this than the way I was about to do it by thinking about parity with a constraint that involves 2s and 7s. So this needs to differ by 2 or 7 from 8. It can't differ by 7 because it would need to be a 1. So it can only differ by 2. It can't be a 10, so it's definitely a 6. Okay, we again can't differ by 7 from 6 ever, so they have to differ by 2. This digit seems not to be able to be an 8, so it can only possibly be a 4. Okay, and now we need to differ by 2 from 4, because again, 7 is out. So this has to be a 2, making that an 8. Okay, and so now this is either a 9 or a 4. Those are the only options. I don't think I know which one it is. Similarly, here from this 8, we have options. We can either go down by 7 to 1 or down by 2 to 6. So this is always going to be a 1 or a 6. Let's see. What if I fill in the rest of this row? Oh, well, I can even actually just place the 1 here. That'll probably be nice. And then these over here, what do I have left? I've got 2, 4, and 9. Well, I can't put 9 with either 2 or 4, so the 9's definitely not going there. Oh, sorry, no, I could put 9 with 2. The only thing that doesn't work is I can't put 4 with 9, but I'm never putting 4 with 9 because of that cell. So actually, this works no matter what. But this digit is a branch because this is going to connect to both of these. Is there anything that connects to both 4 and 9? Yes, the answer is 2. Is there anything that connects to both 2 and 4? I don't think so, but I'm not going to do this. I think I probably could figure out what this has to be, but there's lower hanging fruit, which is that... Oh, I guess I don't know whether this is a 3 or an 8, huh? This could be 3 or 8. But the 3 or 8 needs to connect... both of them actually connect with the 1, 6 actually quite nicely. But this digit, I see. This digit can't... Oh, no, if this is a 1, then these are a 3, 8 pair. So this can't be a 3 because it would force that to be a second 8, is I think what's true, but I don't really want to use that because it's kind of messy, and I assume that's not what I'm intended to do. Let's do some Sudoku instead, and then we'll think about this if we have to, but we might come across additional things just by doing Sudoku. Let's see. This row still needs a 2, which is going to be up there. It still needs a 3, which is going to be over there. Okay, and then these digits are now 5 and 7, I want to say. And these digits over here are 3 and 4, I want to say. Okay, which thing that I didn't really want to use am I going to give in and use? Or am I going to think about this over here? So let's just write in all the possibilities for this in the most horrendous possible way, and that might teach us something. So if this is a 4, the only things this can be are 2 and 6. And if this is a 9, then this is either 7 or another 2. However, this digit is definitely never 6, because if this digit is 6, then the only digit 6 connects to out of 2, 4, and 9 is 4. And I can't make both of those digits 4. So this is never a 6. It's only a 2 or a 7. Now, neither 2 nor 7 connects to 2, actually. Funnily enough. So this can't be a 2, right? Yeah, neither 2 nor 7 connects to 2. So that's not a 2, and this is. Okay, and 7 doesn't connect to 4, which it would have to here. So this is therefore a 2 as well. Now, 2 does connect to both 4 and 9, so that's maybe not the most useful. Speaking of 2 connecting to 4 and 9, 2 connects to 4 and 9. 2 also connects to 4 and 9 in the column. Let's see. 9 connects to 2 and 7. 4 connects to 2 and 6. So that means that digit's a 6 or a 7. I think I was supposed to see something much easier over on this side, which is that if this was a 1, that digit would be a 3. I was fixated on what was happening in this box, and I saw it broke in some combination. But the very easy thing is if... Oh, no, sorry, it would be a 9. Sorry, no, sorry, it would be an 8. This can be 8. Sorry, never mind. 1 doesn't only go next to 3, as I sometimes convince myself and then unconvince myself. Okay, what's left in this column? Maybe that's the easiest thing to do. So we've used 1, 2, 3, 4. So we've got 5, 6, 7, 8 is what is left. So these two definitely need to differ by 2. So these are either 5, 7 or 6, 8. Those are the only options. Should I know which one? Well, yeah, 5 doesn't connect to anything up here. 5 doesn't connect to 4 or 9, so this is never a 5. Let's see. 4 connects to 6, 9 connects to 7. Neither of these connects to 8 either. So this is 6 or 7. And these two need to differ by 2, so this isn't 6 or 7. So this either goes, we can say 6, 8, or 7, 5. And if we're getting to 6, we're getting there from 4. And if we're getting to 7, we're getting there from 9. I feel like there's probably a deduction here that I am meant to have made sooner than I have. Let's see. If this was a 5, then these would be 3, 7. If this was an 8, then these would be 1, 6, both of which seem fine. Okay, let's creep this direction a little bit. So 4 is next to 2 and 6 only. 9 is next to 2 and 7 only. So I guess this is 2, 6, or 7. That's not promising. So if this is a 1, this would have to be an 8, which does go next to 6. This were a 6, this would be a 4 or an 8. Okay, I think I'm going to use a thing I saw before, but that I didn't want to use because it was a little bit beyond my tolerance, but that I think might be worth noting, which is that I don't think this digit can be a 3, because if this digit is a 3, then this digit is a 1, and this digit is a nothing, because the only options are 3 and 8 for things that go next to 1, and this would be able to be neither. There's probably a better step than that, but that's the one I see, so I'm going to take it. So 3 here doesn't work is the problem. So that's definitely an 8. Now, it's also possible that because this is not the intended step, that it actually does stone nothing. It's, in fact, looking very likely. This cell, I guess I can say that if it's 1, it goes next to a 3. And if it's a 6, it goes next to either a 4 or an 8, but it would have to be a 4. See, a 4. This can't be a 4. Because of an interesting problem, which is that if this is a 4, the things 4 goes next to are 6 and 8, but those are both above it. No, sorry, it's not 6 and 8. The things 4 goes next to are 6 and 2, sorry, but they'd both be in the column already, so there'd be nothing for it to go below it. So this has to be a 3, which now means that has to be a 1. We have to differ by 2, which means this has to be a 5. We have to differ by 2 again, so this has to be a 7. These digits are 4 and 6. Okay, these have to differ by 2 again, because there's no, I can't differ by 7 from 7. So these are 5 and 9. I was trying to see if that was resolved by Sudoku. I don't think it is. It means that's not a 5 at least, so that actually gives me a 6-7 pair over there. That's probably not the sort of thing that I should be focused on. 9 here would have to go with a 2. So let's creep this to the middle. The 1 goes with a 3 or an 8. The 1 only goes with an 8 now. That's probably better. 8 certainly doesn't go with 7 or 2, actually. So this has to be a 6. And now 6 doesn't go with 9, so that has to be a 4. There is a 4 over down here. Trying to see if there's more Sudoku stuff, like the fact that that digit's an 8 by Sudoku. One of these is a 5 by Sudoku. Let's see, what digits go next to 5 and 9? 5 goes next to 3 and 7. 9 goes next to 7 and 2. So we know these are from 2, 3, 7, and that one's not a 7. Because there's a 7 in the box, of course. Was not as impactful as I hoped it might be when I agreed to write it into the grid. After I do this, I'm going to have to draw out the graph of what this is saying and see if I'm missing some easy graph theoretic deduction from the rule set. Because there probably is one. But I don't want to write it down right now. 6, huh? See, there's a 5 and only a couple places in here. Eight goes only to 1 and 6. 5 goes only to 3 and 7. Neither of those seem useful. This 5-9 pair seemed like it was going to be really helpful, but I'm not sure that it was. Yeah, 2 goes only to 4 and 9. 3 goes only to 1 and 5. It's all fine. 7 goes only to 9 and 5. Yes, this can't be a 7. Because 7 goes to 5 and 9. Okay, well, the 2 would have to go up to 9. Because it couldn't go down to... Sorry. Couldn't go up to 4. The 3... would have to go with a 1. It couldn't go with a 5 because of the 5-9 pair. So actually that gives us a 1-9 pair in this column. And the 1-9 now touches the 5-8. And I think the point is the 5 doesn't touch either of these. So that's an 8, giving me a 5. The 8 goes with a 6. The 6 goes with a 4, giving me a 9 and a 4 back there. I think I have finally understood what the rules are saying. The rules are saying that you can basically interpret this as add or subtract 2 mod 9 is what the rules are suggesting. So if you add 2 to 8 mod 9, then you get 1, but you never get 9. Right? So that has to be a 1, which means that has to be a 3. So that's a 2, 9, and 1. So probably you're supposed to do something like keep track of the parity flip only happens when you sort of round around the clock. That's got to be a 5. That's got to be a 9. That all works. Okay. 9 were called 0. It might be more intuitive. Okay, so 8 only connects to 1 and 6. Sorts out those. 6 only connects to 4 and 8. Yeah, so I guess every number connects to exactly 2 numbers. Is the so this is just going to be a circle when you draw it out, when you draw out the thing. So you might as well, I guess, once you draw out the graph, I guess you might as well say that these numbers are 1 through 9 and digits along the line are consecutive, but you count 1 as consecutive to 9. And I think you would be doing the same thing, but in a way that is more grokkable. But I think the connections would be exactly the same. Let's see. That's a 2. That's a 3. Okay. So let's see. These are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's the 2. I probably should be doing Sudoku on 2s if I'm getting that kind of thing happening. Yep, so that's the 2. And that is a 2, and that's all the 2s. That's a 3, and that's a 3. I don't know about that. Let's see. 4s. 5s. That's a 5. I see. That's a 5. Where else do I see a 5? That's a 5. Gives me a 7 and a 5. That's all the 5s. Let's see, that's a 6. You see, that's a 6. 7s. I don't see any 7s right away. I've sure got a lot of 8s. Let's see, these two are a 7 and a 9. Which must mean that's a 1. This is a 9 and a 7. And a 9. There we go. Oh, that's not a 1. Sorry. One of these is a 4. It's a 7. 2, 3. That's a 1. 4 and 3. 2, 3. 4. Okay, let's see. These are 7 and 9 in some as of yet unknown order. So this is 7 or 9, but it's the 7. Gives me these two. One of these is a 1. That's a 9. Alrighty, let me actually draw the picture that I had in my brain to try and explain the thing that I was trying to explain that I explained very poorly. Okay, so here is a very poorly drawn vision of what all the connections here look like. So we just have this like ring, everything connects to 2, and they form a cycle like this that's 9 long. So my proposal is that instead of this rule, you just do this rule, which is, I think, simpler and does exactly the same thing, which is to just take along the line any pair of numbers are adjacent or consecutive, but 1 and 9 count as consecutive. And so if you look at this side by side with this Q office meme, it's Pam saying it's the same picture. I think that would be much more intuitive, and I don't think it would change anything at all. But anyway, this is an interesting idea. I do always think that, like, the what can you do with lines? Well, I mean, you can do so many things with lines. It's always quite interesting to sort of contemplate. But anyway, that's going to be all for today's episode. So thank you, everyone, for watching, and I'll see you next time on Invitation to Puzzles. Do leave a comment down below. Let us know what you think of the constraint, and give us a subscription, like the video, and we'll see you next time. Bye for now.